I know that this is exceedingly basic for you and repetitive, but on a very superficial level, everything you just said about the standard model seems to suggest that it is about fields and particles, or forces which are also cashed out in terms of fields and particles that come out of them. And hence that, again, facially, these are the fundamental objects of the theory. So can we just make explicit again why this is the wrong way of viewing the standard model, and that it is the wave function that is the fundamental ontology of the theory?
You're such a philosopher, Robinson. You're never gonna escape this way of thinking about things. It's not wrong to talk about either particles or fields, and I make that point in the book. If the question you ask very precisely is what is the fundamental ontology, then the answer is the wave function, the quantum state, a vector in Hilbert space. But if you ask a different question, which is how do we best understand what's going on? What is the most convenient and useful and informative way to talk about what's going on? Then clearly it's fields and their excitations, the particles. That's okay. The fields and the particles are sort of an emergent way of talking about it, or even a little bit more precisely, they're kind of like coordinates, right? When you have coordinates on a manifold, it's very, very useful to have coordinates. If you want to do general relativity and talk about the precession of Mercury, the first thing you do is choose a coordinate system to work in. But that's not fundamentally what matters, right? It's just a certain choice that human beings make to make their lives easier. Same thing is true with the fields of the standard model. They are a super duper, very useful way of talking about this quantum theory that is fundamentally defined by a wave function obeying some equivalent to the Schrodinger equation.